Salam and hello everyone. Today we're going to be working on the fifth question in the series of physical chemistry slash thermodynamics, and we have this particular question on the screen that says a perfect gas undergoes isothermal compression. So isothermal is just letting us know that we're dealing with constant temperature, so that means the final temperature and the initial temperature are going to be the same. There's not going to be change in temperature, would just equal zero. So there's no change in temperature. And then the word compression says lesser volume. So that means the final volume. So the final volume is going to be less than the initial volume because there's a decrease in volume. Okay, which reduces its volume by 2.20 dm cubed. So that means change in volume is simply 2.20 dm cubed, which is the same thing as 2.20 liters. So I'm just going to, just going to do this right here. So we have space to do all of the problems. So now they gave us the final pressure, P final, and the final volume, so V final, are 5.04 bar. That's for the pressure, the final pressure, and 4.65 dm cubed, which is the same thing as 4.65 liters. Calculate the original pressure. So we're asked to find P initial. Now, the first thing we have to do before we go is to determine what VI is, so the initial volume, before we can go on to solve for the initial pressure. Well, the initial volume is just going to be whatever the final volume is. And so the final volume, which is 4.65, so final volume, right? Plus the change in volume. This is just simply us remembering that since this is a compression situation, we're gonna have an increase or higher volume number for the initial volume. So it's gonna be a plus sign, right? So you already know, like, the situation here, the final volume is less than initial volume, so it's going to have a plus sign, plus the change to the final volume is going to give you the initial volume, since we're dealing with a compression basically. So plus change in volume, which is 2.20 liters. All of them are in liters here. So initial volume is going to be 4.65 plus 2.20 is 6.85 liters. So that's the answer for that. Now, because we are told that we're dealing with constant temperature, we know that we're going to deal with Boyle's law. We also know the number of moles is going to remain constant. They didn't say that here, but they did not tell us about a change in number of moles. So we're going to assume that's constant as well. So what we're just going to do here is for us to use the Boyle's law formula, which is P initial times V initial equals P final times V final. So yeah, that's it. So we're just going to, like, input what we have. We have P initial is what we're trying to solve for. So we're gonna rewrite the formula to be P final times V final divided by V initial. So that's going to be P final is 5.0 bar, okay, times V final, which is 4.65 liters, divided by V initial, which is 6.85 liters. So we're going to cancel out the units, and we're going to just have P initial to be 5.04 times 4.65 divided by 6.85. So what we end up with is just 3.42 bar. So the initial pressure is going to be 3.42 bar, or 421 bar. You can also have that. But since our question is in three sig figs, we're just going to round up. So this is not actually equal to sign. This is estimate. It's actually longer. It's 3.42131387, but approximately 3.42 bars. So we've answered the first part of the question. Second part of the question is asking us to do it in atmosphere. So I'm just going to write that. So question 2 is asking us to do it in atmosphere. So that's just involves a change in units. So if you've not watched my change in units video, and make sure you do watch it. I think it's going to be very important in order for you to solve this. But let's move on. Sorry, what's going on? Okay, so let's move on. Let's do it here. 3.42 0.42 bar, okay, times units conversion formula. We have to have bar at the bottom at the denominator so that the units for bar can cancel, and we have to have atmosphere up top. So we're just going to put the value of that compares atmospheric pressure units to bar units, right? So regularly, we have one atmosphere always equals 1.01325 bar. So we're just going, since we know this is it, this is a standard unit conversion values. We're just going to put that here. So 1 ATM and then 1.01325. And then we go on to do the basic math, cancel out the bar. And so we end up with 3.42 times 1 divided by 1.01325 atmosphere here. So we end up with the original pressure P initial in atmosphere to be, put that in your calculator, 3.42. You can actually use the value 3.421 like and all that before we it becomes 3 sig fix. So you can use 3.421 divided by 1.01325. We can do that instead, since at that particular point we have not, since we're trying to get in 3 sig fix for the atmospheres, and that's how you do proper calculations, by the way. You don't do 3.42 times 1. I'm just showing you this using the estimated value. So 3.42131,387 divided by 1.01325. So you got 3.376574. So in P atmospheres, so approximately the initial pressure is going to be 3.38 atmospheres. So we've gotten the answer in bar, which is 3.42 bar, and we've gotten the answer for initial pressure in atmospheres to be 3.38 atmospheres. I wish you guys all the very best. Make sure you watch the next video that is currently on the screen. Assalamu alaikum wa rahmatullahi wa barakatuh.